This is section 12.5, finding the volume of pyramids and cones. Starting on page 876, number 1, find the volume of each pyramid. So, our formula for volume of a pyramid is 1/3 capital B H. Capital B stands for area of the base, and the H is the height of the pyramid. So, we're given the height, and once again, the height has to be measured perpendicular to the plane that the base is on. So we want this height right here, which will go directly straight up to the vertex point. So we just need to find capital B, the area of the base. Well, in this case, our base is this right triangle. Okay? So our base of the triangle is 9 inches. The height of the triangle is 5 inches because they're perpendicular to each other. Base and height have to be perpendicular to each other for a triangle. So we want half of our base times our height. So we can substitute all of that back in for B. So our volume of the pyramid is 1/3 times 1/2 times 9 times 5, and then times the height, which is 10. And you can just type this all in at once. 1 divided by 3 times 1 divided by 2 times 9 times 5 times 10, and you should get 75, and we want proper units, which would be cubic inches. For number 3, we want to find the volume of a rectangular pyramid with a height of 5.2 meters and a base 8 meters by 4.5 meters. So a problem like this, it's always best to make a diagram so we can see exactly where things are at that we need. So our rectangular base, 4.5 by 8 meters, and our height, 5.2 meters, which is perpendicular to the base of our pyramid. So our volume formula is 1/3 times area of the base times height. Okay, in this case, our base is a rectangle, and that's just length times width. So 4.5 times 9 and then the height is 5.2. So we can just type this all in. 1 divided by 3 times 4.5 times 9 times 5.2, and we get 62.4, and our correct units here in this case would be cubic meters. For number 5, we want to find the volume of the cone and round to the nearest tenth. So our formula for volume of a cone, similar to volume of a pyramid, is 1/3 area of the base. Well, since our base is a circle, our area of a circle is pi r squared. And then we want to take that times the height. So the only thing that's different is that we're substituting this in for B, because B stands for area of the base. And once again, since our base is a circle, that would just be pi r squared, because pi r squared is the formula for area of a circle. So I've identified the height. Once again, the height has to be perpendicular to the base. This is not the height over here. This is actually the slant height. So our height is 4, and our diameter is 7 inches. So to find the radius, take half of that, and you get 3.5 inches, and then you can substitute those values into the formula. So 1/3 times pi times 3.5 squared times height, 4. And just type all that in. 1 divided by 3 times pi times 3.5 squared times 4. And that would round to 51.3 cubic inches. Alright, for number 7, we want to find the volume of an oblique cone with a height of 10.5 millimeters and a radius of 1.6 millimeters. So, an oblique cone would look like this, where our height is one of the lateral edges here. So, we use the same formula for an oblique cone. So 1/3 times pi r squared times h. So in this case, 1/3 times pi, our radius is given, that's 1.6 squared, times the height, 10.5. So 1 divided by 3 times pi times 1.6 squared times 10.5 would round to approximately 28.1 cubic millimeters. And that's our volume. Okay, at number 13, we're finding the volume of our hexagonal pyramid, rounding to the nearest tenth. So since our base is a hexagon and volume is 1/3 times the area of the base times the height, to find the area of the base, whenever you have a regular hexagon, if you take 360 divided by 6, each of these angles would be 60. Basically, you get 6 congruent equilateral triangles by splitting this hexagon up. So, to find the area of the base, we want to take 6 times the area of one of our equilateral triangles. So we have to find the area of this equilateral triangle here. We know that it has a side length of 6, so that could be our base, but we have to figure out what our height is. So if we split this equilateral triangle in half, we would have a 30, 60, 90 triangle, where this edge right here is 3 centimeters, so that's opposite from 30, so that's our short leg. If we take that times 2, we get our hypotenuse. If we take that times the square root of 3, we get our long leg, which ends up being the height of the triangle. So the base of the triangle, talking about this entire equilateral triangle, base of the triangle is 6 centimeters. Height of the triangle is 3 square root of 3 centimeters. So if we want to find the area of our base, once again we have 6 equilateral triangles. So we take 6 times the area of one of those triangles, which is half times base times height. Base is 6, height is 3 root 3, and there we have an expression for the area of the base of our pyramid. So we need to substitute that back in to find volume. The height of our pyramid is right here. It is 7.5. So volume is equal to 1/3 area of the base, which is 6, times 1/2 times 6 times 3 square root of 3, and then times the height of our pyramid, which is 7.5 centimeters. So if we take that to our calculator, we're just taking 1 divided by 3 times 6 times 1 divided by 2 times 6 times 3 times the square root of 3 times 7.5. If we round that to the nearest tenth, we get approximately 233.8. And that would be cubic centimeters. For number 27, we're going to find the volume of this house-shaped solid and round to the nearest tenth. So to do so, we need to add two volumes together. We need to take the volume of the pyramid plus the volume of this rectangular prism. Okay, so the volume of our pyramid is 1/3 area of the base times the height. The volume of our rectangular prism is length times width times height. So we have our length, our width, and our height. And for our base of the pyramid, notice that the base of our pyramid is a rectangle, and it's going to share the same dimensions that we have down here. So our width and our length will give us the area of our base there. And then this is the height of the pyramid. So we can substitute everything in here, and we have 1/3 area of the base, so width times length, height of the pyramid is 9.1, and length times width times height of the prism is 10. Okay, so I notice that we do have two H's here. Sometimes that's confusing. We could, we could put some sort of subscript here so that we don't confuse those two. Maybe put a triangle to represent a pyramid and a rectangle to represent a prism. Sometimes you can do that, or you can put a letter there, just some way that you don't confuse those two. But anyways, if you multiply all this out and add 1 divided by 3 times 20.4 times 12 times 9.1 plus 12 times 20.4 times 10, you should get approximately 3,190.6 cubic meters. And that's our volume.